So the Earth's magnetic field at a certain position on the Earth's surface has a horizontal component of 18 microtesla due north and a downwards vertical component of 55 microtesla. Calculate the magnitude and direction of the force on a vertical wire of length 0.8 meters carrying a current of 4.5 amps downwards. Okay, so let's jump across. Now, what I've got then is the Earth's magnetic field, it's saying, is going in northerly direction, so that's to the north, and it's got 18 microtesla, and it's got a field downwards that's 55, so that's down, of 55 microtesla. Now we've also got a wire. I'll draw my wire in that's at this point, and there's my wire. And the wire's got a current running down it of 4.5 amps. And the actual length of that wire itself is 0.8 meters. Now, we've got two things to work. Well, we've got two things to work out. We've got to work out the magnitude, and we've also got to work out the direction. Now, if I look at this, the first thing is for a magnetic field to have an effect, it has to be not parallel. So this magnetic field here is parallel to the current. Now, if you look at Fleming's good old left-hand rule, it assumes everything's parallel. Sorry, it assumes everything's perpendicular. That has the maximum effect. When they're parallel, it has zero effect. So if you can imagine, I have a field in this direction, parallel wire, zero effect. As soon as I start moving out of that parallel direction, I start getting a component of an effect from a magnetic field. So for this question, I can actually ignore this parallel component. It has no effect at all. The only bit I'm interested in is the perpendicular, and because it's perpendicular, it will have 100% of an effect, or of its effect on the wire. So if I look at this then, what I'm going to do then for the magnitude, I'm just going to do F is equal to Bill. Now F is equal to Bill, I've got 18 times 10 to the minus 6. My current is 4.5 amps and my length is 0.8. So shove those numbers into a calculator. 18e to the minus 6 multiplied by 4.5 multiplied by 0.8 gives me 6.48 times 10 to the minus 5 newtons. Everything is two significant figures. Oh, that's only one significant figure actually. So in theory I should actually be going just to one significant figure, and I'll leave it as 2. I think it's more consistent with the mark scheme. So I'm going to give 6.4, so that would actually be 6.5 times 10 to the minus 5 newtons to two significant figures, though I'd argue that actually it should be to one significant figure because they've quoted 0.8, or did they quote 0.80? No, they quoted 0.80, which is why it's to two significant figures. All right. Now, the second thing, that's the magnitude of the force. The second thing we've got now is the direction. So, if you can imagine, I'm going to